Let's talk about CHECKDB. And I really think in a future version of this course, this is probably going to be the first module I teach, because I think it's something that people kind of get backwards. A lot of us do index rebuilds every day, and then we only do CHECKDB once a week. And I would vote that that's kind of backwards. I submit to you, and I say that now, when I was a DBA, I used to do that same exact thing. I would do my index maintenance every day and then only do my CHECKDB on weekends, because how often does stuff really get corrupt, right? Stuff gets corrupt a lot. It is kind of stunning how often I see corruption these days, now that I'm have a fake job, aka a consultant. But I see people call in with corruption problems all the time. And so a lot of folks only check for it, say, once a week. But then if you find corruption, you got to go back to the last good full backup before the corruption hit and restore all your transaction logs since. A lot of us can't do that. We don't keep a week or 2 weeks worth of transaction logs around. We only keep, say, 24 hours of transaction logs around because we think we always want to recover to a current point in time. And we do. But if there's corruption on disk, we need the entire log chain in order to get back. So what we're going to talk through in here is, first off, are you running the right parameters when you're running CHECKDB? Second, is CHECKDB running fast enough? And if it's not, how do you make it go faster? Third, we'll talk about a few common ways that you run CHECKDB at small scale and at larger scale. And then four, what happens when CHECKDB, heaven forbid, returns an error? What is it? What are the steps that you should go through immediately in order to lose as little data as possible? So first off, the parameters that you're going to be using for CHECKDB, there are parameters that make CHECKDB go faster by checking less. Microsoft likes to tout in SQL Server 2016, it just runs faster. Like CHECKDB, it just runs faster. But some of what CHECKDB just runs faster is it checks less stuff. Well, I wish I could do that as an employee. I just work faster. Brent, you left off half the things on your to-do list. I know, but I'm faster now. That doesn't work. So I've got to keep in mind that there are some parameters I may have to add that will add more time based on what kind of features I'm using inside the database, but I've got to balance that against also my end users want CHECKDB to run as quickly as possible. How do I find that balance? And it's going to be different for every database. Let's talk about the differences that are going to make you choose one way or the other for various parameters. First off, everybody needs to have checksum turned on. Checksum page verification is set at the database level, and having checksum on means that every 8K page that you have, SQL Server is going to write a little checksum at the bottom. I always say the bottom. Doesn't matter where it's at on the page. It's going to put a checksum on this page so that when it reads the page off of disk, it can look at that checksum and say, yes, it's right, or no, it's wrong. It found corruption as soon as it read it. I have a series of blog posts on my site where if you go through and search for corruption on our blog, I show what happens if you don't have checksum turned on, where SQL Server will happily read up and go, yes, you were born in Febtober, or our last sale date was in Toyotathon the 13th. You can get totally invalid data inside your databases if you don't have checksum turned on. The overhead is negligible. It is nothing of any kind of import. You're already waiting to write the page to disk anyway. The computation time is trivial compared to how long it takes to write data to disk. And when you just turn on checksum across through your databases, all that does is say every time that you write an 8K page from here on out, include a checksum on it. But it doesn't cause SQL Server to suddenly go through all of the pages and write checksums onto them. So you can turn it on in the middle of the day and it doesn't break anything. It's completely fine. But now what you have to do is trigger SQL Server to actually write all of those 8K pages so that you start getting corruption detection as quickly as possible. The easiest way to do that is to rebuild all of your indexes, but there should be a giant asterisk over my head when I say that, because easy and rebuilding all your indexes, those two things don't really go well together, because you're generating a ton of transaction log volume, big stuff that you have to send across to database mirroring, always on availability groups. you need to be kind of careful with this. This may be something that you just turn on and you let your regular index maintenance jobs go for a while. Then you go back and proactively rebuild any indexes that haven't been rebuilt lately. Then I want to run CHECKDB against all of my databases as frequently as I can. I used to say as frequently as possible until we ran into a company that was doing it every hour. And they were having performance problems, of course, duh, but we said, why would you do that every hour? And they said, well, you said do it as often as possible. Well, okay, all right, that's not quite right. I'm a huge fan of doing it every night, especially if it's stuff that's, say, 50 gigs or less. You can usually run CHECKDB on stuff, especially that's 10 gigs or less, without end users noticing an impact. But you get above the 10 to 50 gig database range, and that suddenly starts to become a whole lot harder. We'll talk about the boundary at which you draw as we start to go through here. When I say every database, there's one database that's built in as a system database, and it's not obvious when you look in system databases in SSMS. There's this resource DB that's hidden where system objects go. It's maintained every time you do a SQL Server update, like a cumulative update or a service pack that needs to change indexes or objects inside there. Resource DB is automatically checked whenever you run a CHECKDB on master. It's not something you can control or do anything about. Just make sure that you do check your system databases just as you would user databases. Often I see people only doing CHECKDB against user databases. You need to know when system tables start to become corrupt, and they're often on a different drive than your user databases. So I need to make sure that that thing's okay. I want to run CHECKDB against him as well. The way that I check checksum settings is the same whether it's a user database or whether it's a system database. What you do is go through and run DBCC DB-info. And if you do it with the table results, it's going to go out and dump out this stuff into a table form instead that makes it just a little bit easier to query. I personally am a fan of doing this with SPBlitz instead, just because in SPBlitz I've written in the code so that it checks when your last CHECKDB is, as well as what your checksum settings are. We warn you if any databases don't have checksum turned on. The biggest cause for this is usually that we had a database built with a development tool that specifies old database options, or that we inherited a database from like the SQL Server 2000 days and no one just ever changed this to checksum. So checksum starts writing these pages, starts writing the checksums to pages to disk. But now, make sure I said that right. But now it's coming time to run DBCC CHECKDB to check those checksums and other things on your pages to make sure they're actually correct. There are 4 common parameters. You don't use them all. You're going to choose which ones you want to use. Data purity, no info messages, extended logical checks, and physical only. Go through each of these individually, starting with data purity. This is one to make sure that you don't have Febtober or Toyotathon in a date field. It's supposed to be done automatically by default, but there are specific bugs that will cause it not to be run, for example, in master and model. Just throw this on regardless. It doesn't influence runtime. And if it did influence runtime, it's because you were hitting one of those bugs where it skipped when it shouldn't be. This is something that Ola Hollengren just turns on for you. Again, I push Ola Hollengren's scripts a whole lot through here. This starts to become one of the reasons why. If you didn't know about this and you were coding your own CHECKDB scripts, why bother? It's just another reason as to why you shouldn't do that. So this is a parameter that you should include by default. Number 2 is with no info messages. I would argue that this is also something that you should turn on by default. By default, CHECKDB has what Stephen King, the author, calls diarrhea of the word processor. It just dumps out page after page of results, things that don't really matter, aren't all that important, things that you don't really care anything about. CHECKDB found no errors, no errors, no errors. And when you're trying to find out where the errors are, and you're facing a wall of CHECKDB output, the first thing that you do is type Control F for find, and then you put in the word error, And guess what you keep hitting? No errors, no errors, no errors. I want to skip all of that so that just only the things that are problematic stand out to me, because CheckDB's output isn't color-coded either. So I also tack on no info messages, and this doesn't increase runtime at all either. This makes it just as fast as CheckDB would normally run. Now we get into the two that are changing how CheckDB runs in terms of runtime. First one's extended logical checks. This makes CheckDB do more work to check more stuff. Classic examples on this are indexed views, XML indexes, and spatial indexes. All three of these are relatively rare. If I had to guess on a percentage basis, I'd say 1% of databases has an indexed view in it, and even less than 1%, maybe 1 in 10,000 databases has an XML index or a spatial index. So they're pretty infrequent. These are only checked if you turn on extended logical checks. And Microsoft says, we don't think you should bother checking those unless you expect corruption. Why would anyone ever expect or suspect corruption? SQL Server, you're supposed to be doing a good job here. You shouldn't be writing trash data to disk, and my storage isn't supposed to be corrupting my data either. What are you trying to say, SQL Server? Why would I suspect? Oh, that's why I would suspect. So it turns out there are known bugs in SQL Server that will cause CheckDB just by default to look like, and let me rephrase, I'm going to rewind how I'm saying this. So there are ways that you can write T-SQL that will trash data in the database. I'll show you what the bug is on the next slide. But in this example, after I purposely trash the data in my database, CheckDB returns fine. It says no results, no errors are found. But CheckDB with extended logical checks does give me this problem. Oh, God. So this is bad for me because I want to find these errors before my end users do. This is the bug that's involved in that particular one. A bug with an indexed view gives me update problems with a merge, if I remember right. This is the worst kind of corruption because your users, when they run a query, will see data that they think is legit. However, if you run CheckDB with extended logical checks, SQL Server will say, wait a minute, you know what? The data that's in the indexed view doesn't match the data that's in the underlying tables. This is the worst kind of incorrect results bug. SQL Server has incorrect results bugs all the time. But when I see data with no errors and it looks cool, but it's the wrong data, that's a problem for me. So should I use extended logical checks? My personal feel is if the business users are making decisions based on what comes out of those indexed views, XML indexes, spatial indexes, if this is mission critical data to the business, I do need to check those with extended logical checks. It shouldn't add that much more time unless I've gone wild and crazy spring break with the indexed views and the XML indexes. Although one could argue, if this is a data warehouse, and we're using lots of indexed views in a data warehouse just to make reporting queries faster, does it really matter if the data's right? Because in a lot of data warehouses, users are just using this for executive queries, and let's face it, they're going to make that data look like anything they want anyway. They're just kind of make bad decisions based off of bad data anyway. It's just like the data might as well be random. I'm kidding. The next parameter is physical only. Now, extended logical checks does more work. Physical only does less work. It says, don't worry about Febtober. Don't worry about Toyotathon. Don't worry about bad data in indexed views, non-clustered indexes compared to clustered indexes. Just go through and look at every 8K page and tell me if the checksums are right or not. Because most of the time, this will catch most of the corruption errors, but not all of them. There's a similar parameter that sounds like it's going to check less stuff, and it's called NOINDEX. NOINDEX skips all of the non-clustered indexes in our database, which is also meant to speed things up. But that's not really the same thing. Let me give you an example using AdventureWorks. So let's say I've got AdventureWorks here. I'm going to restore it. And then I'm going to go through, I'm going to skip this just because this doesn't really matter who the owner is. I'm going to go take one of the indexes in AdventureWorks, and I'm purposely going to trash just one of the indexes. I have this table called contact type that has things like manager, chief executive, accounting manager, payroll assistant. I've got the clustered index of the table. I'm looking at the output of SP Blitz index here. I have the clustered index of the table. That's not the one I'm going to corrupt. I'm going to corrupt the non-clustered index of the table, which is the second copy of our data, so to speak. What I'm doing is looking in for that contact type table. Show me the 8K page for my non-clustered index. DMDB page allocations, frankly, is only useful for demo queries when I'm going off and spelunking to see which 8K page I should go corrupt. This is one of those functions that I always feel guilty even showing you because it has no practical real-world use until you want to go corrupt some demo data on purpose. So I'm looking for just the allocated pages for this one particular index. Oh, let me go back. I found it. It's page 4,995. This is the page I'm going to go corrupt. So let's go set the database offline so I can go edit it. I'm going to go edit it with my handy hex editor. And then I'm going to jump forward. If we're talking about page 4995, I need to jump forward 4995 pages times 8K. That's where I'm going to see the contents of that particular index. And sure enough, here it is. If I jump forward by about 40 megabytes, here's the different contact types that I have. Assistant sales assistant, assistant sales agent, assistant accounting manager. I'm going to change accounting manager to accounting manager, like someone's mom. And then I'm going to bring the database back online. Now I've only corrupted the non-clustered index, not the clustered index. So when I run CHECKDB and I do it with the NOINDEX parameter, SQL Server skips all of the non-clustered indexes. So it does run faster. In comparison, the parameter for physical only does catch this because physical only reads every page, regardless of whether it's an index or a clustered index or off-row binary data, whatever. It looks at every page and just checks the checksum. It does wonk out, you have a problem, page 4995. This is the one we just corrupted. So physical only catches things that NOINDEX wouldn't, and I want that because that's what my users catch. After all, the indexes that I make, my users query. And I don't want to look like an idiot when they run a query and find database corruption. I would rather find those things ahead of time before they do. So I am a fan of physical only. I am not a fan of NOINDEX. So how often, if I choose to just balance it out by only doing physical only, just looking at all the 8K pages, how often should I do a full CHECKDB? And in relation, Fred also asks, how frequently should I suggest doing CHECKDB on read-only databases? This all comes down to this. If I have any kind of corruption, how much data am I willing to lose and how long am I allowed to be down for? It all is just based on a restore speed conversation. If the business says you've got to be able to come back within 1 hour, and if I don't have database mirroring or always on availability groups, that means I have to be able to do a restore in 1 hour. That may not sound hard, but imagine that you're only doing CHECKDB once a week. You may have to go back to last week's good clean backup before the CHECKDB and all the logs since. That's where it starts to get hard to meet that 1 hour decision point. On read-only databases, it's the exact same thing. How long does it take you to restore the database? That dictates how often you should run CheckDB and whether or not you need a secondary, some other SQL server that you can fail over to. If the business says we need to be able to recover from corruption in 30 minutes, even when it's a read-only database, if I have a 1 terabyte read-only database, I may not be able to restore that in 30 minutes, especially if we count the getting sober time getting to a keyboard. So I may have to have some other standby box there. When the business says, well, you know what, that's okay. If it's corruption in a read-only database, we don't care. Then you change it. Then you just change the RPO and RTO. So great. We agree then that it's 4 hours because that's how long it takes to do a restore. And usually the business will say yes. Next parameter that we want to play around with. When I'm doing CheckDB via an agent job, which is how everybody runs CheckDB, just because you want it to happen frequently on an interval, like every day or every week, you want it to append everything to an output log. I want a file out here where CheckDB's output goes to. You get in there certain tokens that you can use, and SQL Server will replace your tokens on the fly. So you can have a different file for every day and for every step in a job. This way, if I have CheckDB in one step, index rebuilds in another step, backups in another step, I want a new file for every single day. These files are tiny, and you can set up a cleanup job that will go through and clean these things back out. You want an output log file because CheckDB takes forever to run. Whenever disaster strikes, if someone says, oh my God, the CheckDB job failed, if I just go look into agent job history, it's only very short in terms of text. It doesn't give me everything that was broken inside the database, and I don't have the time to go back and run CheckDB again. I want to be able to just glance very quickly at the output and say yes or no whether or not I need to restore this entire server from scratch, or whether I can just blow away specific indexes and rebuild those or recreate them from scratch. Speaking of which, is CheckDB running fast enough? This is the biggest complaint that we run into when people say have dozens or hundreds of agent jobs. Well, first off, just do you have a problem with maintenance job runtimes versus end user activity windows? If you run the kind of shop where, as especially often in those read-only servers that Fred's talking about, often the activity on those simply tails off at, say, 6 or 7 p.m., and then it's mostly idle most of the night. Run CheckDB every day. Just run CheckDB every day. Don't worry about it. Is it going to give your storage subsystem a workout? Yes, absolutely. But it's going to keep you from having to respond to emergency problems where we have to go back and restore from a long, long time ago. Now, if users are complaining about my nightly maintenance windows, especially in things like data warehouses where they say you have a limited amount of time where you can really thrash this server, the first thing that I'll go look at is what else is running around the same time. I see so many shops where people use a default schedule just for starters. They say, all right, everywhere we're going to do our full backups at midnight, we're going to do our CheckDB at 3 a.m., and then they never go back and look to see, are things overlapping now? Over time, your full backup job targets grew longer and longer for that schedule. And now both CheckDB and your index rebuilds and backups are all running at exactly the same time. Recipe for performance problems. In a perfect world, I'm going to stagger all of these jobs. SQL Sentry has an event manager product that gives you your events on a calendar. So you can see on an Outlook calendar where your jobs overlap. They even let you drag and drop them around so that they can move their schedules and not overlap anymore. Even works across multiple SQL servers, which is really useful under virtualization. A lot of us have, say, 50 virtual SQL servers, and they're all running on the same host, and they all start their backups at midnight. So the VMware host is just walking along, everything's going cool, and then all of a sudden at midnight, it bends over howling in pain because every CPU is going up to 100% all the way across the board. Next question is tempdb fast enough? This isn't the first bottleneck I go hit. Usually it's the matter of staggering job times. But once job times are staggered, CheckDB places a tremendous amount of load on tempdb, What you'll want to do is monitor perfmon counters during the time when CHECKDB runs and look at the average disk seconds per read and seconds per write. Generally, I'm going to aim for 30 millisecond response times on reads and 2 millisecond response times on writes. If you're using traditional shared storage, those may seem like hard numbers to meet, and they are on shared storage. However, this is why you use local solid state for tempdb when you need to scale. This is a tough discussion when I talk about, people immediately hear this and think, but I'm in a virtual environment. In a virtual environment, my tempdb is generally on shared disks, not on local SSDs. How am I supposed to react to this? Well, remember, step back a few slides. First, you need to ask if you even have problems with a maintenance window. And then second, stagger your job times so not everyone is trying to write to the same LUNs for tempdb at exactly the same time. Once you've solved those two problems, the next one is CHECKDB using parallelism. Under Standard Edition, CHECKDB is single-threaded. Under Enterprise Edition, it's multi-threaded, but it obeys your maxdop settings. And I know a lot of folks who run SharePoint or Dynamics, and they follow Microsoft's recommendations to set maxdop 1 at the server level. But that also sets it for CHECKDB. Once you throttle everybody to maxdop 1, that includes CHECKDB. If you want to play around with that, you could either change maxdop settings at the time CHECKDB runs, like the first step in the job for CHECKDB is go change it to maxdop 8 or 12 or whatever makes the most sense for your CHECKDB. And then after CHECKDB finishes, set maxdop back to the usual thing. This is dangerous for two reasons. One, I hate making system table changes when I'm not around. I don't like having those things changed in an automated fashion. I'm okay with it, but I want to make doggone sure my scripts work perfectly, because I can tell you a lot of stories about how when someone's job failed halfway through and then it left maxdop at the original setting from the start of the job. The second problem with that is whenever you run spconfigure or spreconfigure, when you run spconfigure, change maxdop, and then run the reconfigure statement, that blows the plan cache. Not all spconfigure changes make that, but changing the max degree of parallelism does blow the plan cache. In something like a data warehouse environment, you may not care because your plan cache isn't that useful day to day. But if you're in a mission-critical OLTP server, it does. Next, are you using any features inside your database schema that change how CHECKDB performs? Partitioning is a classic example, filtered indexes on sparse columns. All these are known to supposedly cause big performance differences in CHECKDB. But to get people to stop using these, that's a really tough conversation. That's why this is later on in the list. After I've exhausted those earlier options, then I start turning around over to my developers and saying, all right, what could we do in order to make CHECKDB faster? You can help me here. Finally, there's two trace flags that you can use. These are designed to speed up the physical only option. I've actually never seen these make a significant difference in most of the servers that I manage. However, I do have clients with 10 terabyte and larger databases that do swear by these. At 10 terabytes and larger, they say these things make a tremendous difference for us, especially that bottom one where I deal with SQL servers that have, say, 50 or 100 different data files, and they're all on the same drive letter, but they're on different mount points. These are left in here more as a reference than anything else when you hit that weirdo edge case. There's also a known bug in CHECKDB on 2012 prior to SP2CU4, where CHECKDB will ask for a tremendously large memory grant. For example, I got one client that runs 1 to 2 terabyte databases on their servers. Their SQL servers have 768 gigs of RAM, and every time CHECKDB runs, it wants half a terabyte of RAM. It doesn't actually need half a terabyte of RAM, and it can't get it by default. Resource Governor caps your grants at 25% of RAM. But 25% of RAM to grant out to CHECKDB is a pretty honkin' big deal. And you feel that when CHECKDB fires off. We had a question today in office hours about what could cause page life expectancy to fall off a cliff. This is one of those examples where CHECKDB runs, asks for a tremendous amount of memory. SQL Server's buffer pool looks like it can't keep anything in cache, but it's just because we evicted a whole lot of stuff in order to run CHECKDB. Real world-wise, how much of a difference do these things make? When I step back and add up all these different performance switches, what I'm going to do is I'm going to take the Stack Overflow database and I'm going to run it on a laptop. The reason why I say I'm going to run it on a laptop is it's all solid-state storage in this particular laptop, so it gives you a really good idea of an overcommitted SQL Server. Say a 50 gig Stack Overflow database running against a laptop could cause problems. In here, CHECKDB Stack Overflow, whether I use with data purity or without, I come in at around about the same runtime. This is minutes, not hours. And then CHECKDB Stack Overflow with physical only, meaning just glance at every 8K page and see that it has the correct checksum. It's more than twice as fast. So I could totally see running with physical only all week long, and then just running with data purity, say, once a week. Because this one should catch all disk corruption issues, but then this one will also catch SQL Server bugs. And I say with this one, just with any CHECKDB altogether, will catch SQL Server bugs, which can make a difference for me there. But if it's only in an index, I could just drop that index and recreate it. In mine, I had a non-clustered index on a computed column. Here, for me, I've never seen it make a tremendous difference. It's not large, but at the multi-terabyte database, I have seen that make a difference. So stepping back and looking at the big picture, with everything we've talked about with CHECKDB, there are the three common use cases that I see for how often you should run it and where you should run it. Starting out with if you only have a few databases, and I mean, say, a dozen or less. If you have a dozen or less user databases that are around 10 to 50 gigs, run CHECKDB on the server every night. Now, I know that that's a big range, going between 10 gigs and 50 gigs, because we're talking about the difference between overall maybe 100 gigs worth of data to nearly a terabyte of data. But at the 10 to 50 gig range, it's fairly hard to notice the difference on reasonable hardware. Yeah, if you pack in the databases like clown cars, if you're running a VM with 2 cores in it and 8 gigs of RAM, you will notice the performance difference. But I need to be able to detect corruption reasonably fast. The reason that I say reasonably fast is in smaller shops where I don't have a whole lot of SQL servers, often they don't keep a whole lot of log backups on disk. They only keep, say, 24 hours of log backups on disk. What happens if every weekend I run a CHECKDB, it comes back clean, then I have a full backup that runs on Sunday, and sometime between Sunday and Monday, and I don't know when, I had storage corruption. After all, storage corruption doesn't tap you on the shoulder when it happens. It doesn't say, hey, Brent, I just corrupted your storage. I don't find out until someone reads that data. And if no one reads that particular area of storage that was corrupt, Sunday goes by, Monday goes by, and we're only keeping the last 24 hours of transaction log backups. When a user reads this and says, oh my God, Brent, we're having errors in our SQL server, and I get in and work on it, if those log backups are gone, how much data am I going to lose? Well, if I restore for the Monday backup, it doesn't help me at all because this data is already corrupt in Monday's backup. The only way that I'm going to be able to recover those rows is to jump back to Sunday's full backup. And even then, here I'm drawing an arrow to show you where the corruption hit, In the real world, you don't know if it didn't hit right here in between the CHECKDB and the full backup. To be really safe, you want to go to the first full backup before the CHECKDB. Now, if it's your job and the boss comes in afterwards and says, I want you to go ahead and lose less data. What could we do to lose less data going forward in the future? You have two options. You could either run CHECKDB more often. For example, if I ran CHECKDB Sunday night, it would have detected the corruption and I still would have had the log backup files. Or I could keep the log backup files longer, like going all the way back to the last clean full backup before the CHECKDB. It's totally up to you which one you choose, either running CHECKDB more often or keeping more backup files. Either of those is useful when I'm talking about just a few SQL servers and with a relatively small number of limited size databases, 10 to 50 gigs in size. Things get better bigger at the enterprise level, where we start to talk about dozens or hundreds of SQL servers hosting hundreds or thousands of what I'm going to call small databases. Those of you who have databases that are 50 to 100 gigs, I get it, those can seem large, but these days, if you look at a bell curve of what's normal with SQL Server, most shops have databases in at least the 1 terabyte mark, if not larger. Largest one I've seen recently is about 80 terabytes worth of stuff on a single SQL server. So what you can do is start, of course, by running with no info messages. This is just important at this scale because when I have hundreds or thousands of databases, I don't have the time to go through and decipher a big, long, huge output out of DBCC CHECKDB. I just need to be able to quickly scan through that output. When I have that many servers, it can be easier to use the restore and check pattern. If I have 1,000 databases on a single server, I may not be able to get through CHECKDB on it every night. Instead, I'm going to restore the backup over to another SQL server and run CHECKDB over there, offloading it. Tools like Redgate SQL Backup, Idera SQL Safe, and Quest Lightspeed have this built in, but like we talked about in the backup tuning module, you may not be able to afford that across large numbers of SQL servers. You may have to roll your own. And the next time I deliver this module, I got to add in a slide on minion CHECKDB. I'm going to make a note of this here fast, really quick before I forget it, because this is such a neato idea for a product. Let me get this out here. Where's my note page? There it is. 51, add minion. So the reason why, Minion, the Midnight DBA folks, Jen and Sean McCown, have this product called Minion CHECKDB. And I say product, it's totally free. It's a free script. They give it away to you, and what it'll do is it'll do things like restore onto the database server that you choose. It'll email you. You can set up a rotation of which databases you want to be checked when. It'll break it up into file groups for you automatically. Like if you have one monster database, it'll do different file groups every day or however often that you want, even splitting them out across multiple servers. I haven't used it myself yet, but going through the documentation, I'm like, this thing is amazing, and it's the first innovation that we've had in the CHECKDB area in a long time. If you're in the category that we're talking about here, the hundreds or thousands of databases, and you can't run CHECKDB every night in production on your main servers, I would strongly check out Minion CHECKDB, because I don't want you reinventing that wheel. Jen and Sean seem to do a really good job on building enterprise-ready code, just like Ola Hollengren does on the maintenance scripts. Ola Hollengren does have CHECKDB, but only on the production server. Minions is designed to scale out to other SQL servers to offload that stuff. It does have to be a full backup and a full restore. You can't use log backups, because log backups don't contain the data pages. They just contain instructions on what to do to the data pages. This is kind of tricky with log shipping and with database mirroring. Could you run CHECKDB, on those other servers? Well, yes, but you're only checking those servers. You're not checking the primary server. So the only way it works to offload CheckDB to a logship secondary or to a mirroring secondary is if you encounter corruption on the primary, your first reaction is going to be to fail over to the logship secondary or the mirror. Now, of course, mirroring automatically gets you automatic page repair too, but there are some kinds of corruption that automatic page repair can't repair involving system pages. It's fairly rare that I see people willing to fail their whole server over as soon as they encounter corruption, which I've always found kind of goofy, because as a DBA, that's what I want to do. I want to get out as quickly as possible. I don't even want to bother repairing corruption wherever it sits. I want to fail over somewhere else that I know has a clean copy of that data and log file, because wherever there was corruption, I simply no longer trust that I/O subsystem at all. This is one of the things I passionately love about always-on availability groups. Sometimes people will say, well, always-on availability groups, I can offload CheckDB to another replica. And that's true, but you're only checking that replica. You're not checking any others. A great story out of that. I had one shop where they were running CheckDB on one server and running their backups on another. One day they found that they had to go restore from backup. Somebody dropped a table, and that table was corrupt in that backup. Now, yes, the AG replica had a clean copy of the current table, but the guy had already deleted a bunch of data out of there. So we had to go back to the backup, and that backup was corrupt. Ironically, while you might think that you can offload CheckDB to other replicas, the real answer with availability groups is you just bought yourself the right to run CheckDB on more replicas, because after all, you need to make sure that whenever you fail over, you're failing over somewhere that's clean, not somewhere that's corrupt. The last pattern is what happens if you have a VLDB. The business definition for VLDBs, very large databases, is either 1 billion rows in a single table or 1 terabyte in a single database. When you're at that scale, it's really hard to do CheckDB in production. Here, offloading it is just kind of a requirement. You've got to be able to restore somewhere else and then run your CheckDB over there. But when you're at the 1 terabyte level, running CheckDB may not be an option. A friend of mine manages a 15 terabyte database, and he would love to run CheckDB. It's just impossible. It would take a week or more. So what you have to do is you have to start breaking CheckDB into chunks. You can check with file groups. You can check specific tables. But when you go down this route, just make sure that you spreadsheet or sketch out all of the objects in the database, and whatever script you build needs to make doggone sure that it catches everything in the database, especially new objects that get added after your script is written. Again, why I would probably lean you towards, if you're even thinking about doing what's on this slide, go check out Jen and Sean's Minion CheckDB. I would much rather bet on their scripting skills than I would any of yours, better than any of mine. I wouldn't write a good CheckDB compared to what those guys are putting into their scripts. Finally, the last section, what happens when CheckDB reports an error? Or whenever users run a select and they get a warning, or an insert, update, or delete, that comes back with a warning, sorry, you're going to have to go run CheckDB. I get this question often enough, and I don't take this work, actually. If someone calls in with a corrupt database, because the problem is they want it to be fixed right away, and I'm usually busy doing something like training you incredibly attractive people right away, and I can't drop what I'm working on. So what I did was I wrote out, and this is a long blog post, everything that I do when I go tackle a corruption project, because sometimes I get lucky. It's a perverse meaning of luck. Sometimes I get lucky and this happens on a weekend where I do have time available. Here's my whole thought process. Now, I'm just going to show you step 1 on the blog post here on the slide. Query suspect pages. So this system table will go give you a list of it's 1,000 corrupt pages, the last the most recent 1,000 corrupt pages. It's a little tricky. You can actually delete out of that table, so I kind of have to be careful when I say it's the most recent 1,000 pages. Someone could have truncated this table. Heaven forbid you have people on your team who would do that. But what I like is when I query that, if I see that more than one database is affected, I immediately want to hit the big old abort button. I keep a little widget on my desk here where I can push on things. The big old eject button right away, get me out of here, because I have an emergency. So what I do is email my manager, my team, and everybody who's a stakeholder in that app. I give you contents for an email right here to get started. I do this throughout the blog post, so you can just copy paste in. SQL Server blank just reported corruption across multiple databases. This indicates that it has storage problems. We need to fail over to another SQL Server immediately, come to MyCube or Skype or whatever so that we can discuss our options. Because once you do have corruption across multiple databases, it really likely is a storage problem, and I got to get out of there as quickly as possible. Then through the blog post, I lay out several other steps. For example, if it's only one database, it may not be a storage problem. I'm not ruling out storage, but it just may not be that much of an issue. It may also be a SQL Server issue instead, like that indexed views bug that we talked about. If I'm on shared storage, I'm going to alert the storage team. I have a very polite email in there. I don't know that it's a storage problem, but I want my storage team to be aware of it. I'm not going to ask them to report back to me. I just want to give them the heads up. I know I joked in an earlier module that I love pushing people under the bus. Corruption is not one of those times. I don't want to blame anybody because it could be coming from anywhere, including SQL Server. Even if it's coming from the storage, it's most likely not my storage team's fault. Storage breaks a lot, and I'll tell you about one of those stories tomorrow during the SAN module. I have a great picture from my cubicle with a big vendor SAN engineer hunched over my desktop trying to fix our broken SAN that he broke, not me. Alert the application owners and stakeholders. Turn off your backup delete jobs. The reason why I say that is you may have to quickly go back and get to a prior point in time or get all your log backups leading up to a point in time. I need to make sure that we're not deleting any of those. Otherwise, as time marches on, I'm losing my ability to restore. Then review the history of my CHECKDB full and log backup jobs to see how much data I'm about to lose or sketch it out with the team. And then if I have the full CHECKDB output, if I'm really lucky, it might be a non-clustered index that I can simply drop and create again. And I give you a pointer to Gail Shaw's excellent blog post on how to read the output of DBCC CHECKDB. It takes time. On step 7, that's easily half an hour of your life to go in and interpret that. So I've got to set good expectations with management as I'm going through this checklist. Finally, in step 8, here's where I parallelize the work. If we get to step 8 and we haven't found a fix yet, I break this work out across multiple teams, usually on multiple different servers, and I give you the work that each of those team members needs to do. This blog post is really meant to be like a management approach to CHECKDB and corruption, not repair, but just finding out how bad the corruption is and what you're going to have to do in order to recover from it. After the emergency is over, whenever you find CHECKDB problem, whenever you find corruption, this is when management busts out the wallet and says, how much could we pay to never have to deal with that again? And then this is where we start putting our RPO in writing and for every one of our SQL servers. And I can talk to the business about here's how much data we'll lose and here's how long we'll be down for in the event that we come to these kinds of issues. This is when management starts to allocate more backup space, more CPU power to run CHECKDB more often, good stuff like that. So it's kind of a long module, and so what we try to do is break it all down into one single slide that will give you a best practices overall for running CHECKDB. I hope I've started to convey some of the importance of what a big deal this is and why you want to run it more often. This is one of those career-ending type moves when you uncover widespread corruption. And great example out of one of the shops that I worked in. When I walk into a shop, I have an email that goes out ahead of time, and it says what to expect when I arrive. It's kind of like my contract writer, where it's like, here's what I need when I show up. One of the things that it says in there is I'm going to default to the same clothes I wear at a conference. I'm going to wear a t-shirt, sweatshirt, and jeans. Tell me if that's not right, and I'll wear something else. You just have to tell me. So I walk into a client, downtown urban, big urban high-rise. Walk into this big, gorgeous conference room, huge conference table, 20 DBAs circling around this conference table, all wearing suits. Not just ties, suits. And I'm like, did I walk into the wrong... Is this actually the database team? Yes, this is the database. We've been waiting for you. Come on in. We'll talk about our database servers. And the first thing that I always do as a consultant is I run SP Blitz, because I just want to make sure that the databases are backed up and that there's no corruption. It's not that I won't work on a server without backups or that has corruption. I just need everybody in the room to understand how dangerous it is first. I wasn't there to fix a backup or a corruption problem, but better safe than sorry. So we run SP Blitz, and the first thing that pops up is there's corruption in several of the databases. Now here's Brent in his t-shirt and jeans, surrounded by DBAs in suits, none of which take Brent very seriously. And they all say things like, well, your script must have an error. You must have a bug there. And I'm great at playing dumb. I love playing dumb because I am kind of dumb. Really good at it. So I just said, oh, you're probably right. Let me just see real quick. They said, we run CHECKDB every week. It's been running fine for years. We've never gotten any errors out of it. I said, oh, it probably is a bug on my side. Let's just open up that CHECKDB job and see what's going on. So they open up agent and they open up the list of jobs and they go into job history, and there's a line of red X's right next to the CHECKDB job. All of a sudden, everybody in the room starts sitting up a little straighter. I said, oh, you know what? It's probably not failing because of corruption. There's probably just some kind of thing in the job that's broken. Why don't you go in and take a look at the history? And they open up the history and corruption. Now everybody's sitting up really straight. And dumb old Brent in the t-shirt says, well, you know what? I'm sure it's probably just something small. It's not a big deal. But you said you weren't getting any errors. What's going on with that? So they go in and look at who was supposed to get the emails when the job failed. And it was an email address for a guy who'd left the company years ago. And no one had gone back to change all of the notifications. Turned out, we found out that day that they had rampant corruption through several databases and had to tell their clients that they had permanently lost data. I don't want you to be in that situation. I don't want anybody to be in that situation. That's why we raise corruption as a Sev 1, Priority 1 error in SP Blitz, warning you as quickly as possible, and want to get you off on the right start to running CHECKDB as frequently as practical. Not every hour, but just as frequently as you practically can so that you don't get into trouble around your RPO and RTO.